To understand the above, let's take an example of a molecule and let's work out the similarity transformation. The molecule that we will consider here will be ammonia. Okay, so the structure of ammonia is trigonal, or you can say is a tetrahedral, but for our case, so the structure எப்படி இருக்கும் அப்படின்னா, so this will be the structure. Okay, so that's the structure. அதாவது இந்த bond வந்து it's coming towards you, this bond is going away from you. இதை வந்து நம்ம மேலே இங்க இருந்து பார்த்தோம் அப்படின்னா, இங்க இருந்து நம்ம வியூ பண்ணோம் அப்படின்னா, the molecule will look like this. Okay, please note this is not a planar molecule. In this, so we will define the symmetry elements. The symmetry elements of NH3 or ammonia is E, C3, C3 twice, sigma V dash, sigma V double dash. So there are three vertical planes, there are two rotational axes, and there is an identity element. Now we will define each of these vertical planes. How do we label them? Right. So what do? I put this as one vertical axis. Okay, so this is this one. Then I will put green for this one. So I'll put this one as, so this is, so this will be your, okay, I'll label it later. Now another one I'll make it as say blue. So this will be here. Okay, good. And I'll call them as sigma V double dash, sigma V dash, and sigma V. Okay, and I label the hydrogens as 1, 2 and 3. So it's always in the clockwise direction. Okay, so you start from the top and you move clockwise and label them as H1, H2 and H3, right? So for the sake of clarity, I'll draw it once again here. Please remember, always start labeling from the top. Okay, now I have to do this similarity transformation by all other elements. The first element I am taking is E. So I have to do a similarity transformation of this with all the elements. So first element is E itself. So I have to do this. I have to do this C3 inverse. Then I have to do C3 2 inverse. Then E sigma V inverse. E sigma V dash inverse. Then E sigma V double dash inverse. Right. So the first thing that we will do is this operation. Okay, so let me just copy this and paste it below. Okay, now let me do the operations. So the first one is, so I'll have to go from right to left. So what is the first operation? E followed by E inverse. So first I'll do E. What will happen? The molecule will remain the same, no change, because I'm doing an identity operation. So the molecule will remain the same. Again I'm doing E operation. So again the molecule will remain the same. Now I'm going to do E inverse. Inverse of identity is identity itself. Okay, E itself. So I'll take this one. So now what I have to do for writing the result of, so what is this? The net result is E inverse. Okay, so what is the net result? To get the net result, you have to compare your initial configuration with your final configuration. So you should see what is the relationship between the two. Now you will notice that the only relationship that exists between the two is that E. So the answer is E. Right. So I'll go up and I'll write this answer as E. Let me do the this part. Let me do this C3 inverse. Okay, so I'll just remove all this. Okay, I'll remove the labels. Okay, so this will be H2. So I'll remove the labels and okay, right. Okay. Now if you look at here, so I have to perform a C3 first. So if I do a C3, that means I'm rotating it by 120 degrees. So if I rotate this by 120 degrees, then H1 will move to H2. H2 will move to H3. H3 will move to H1. Now I'm doing an identity operation. So if I do an identity operation, nothing changes. So the things will remain as is. Now again I have to perform a C3 inverse. Now what is C3 inverse? How do I find it? Okay. So this I didn't have time to discuss in class in detail, but just in case people want to understand, okay, I'll do it again. So I don't know what is the inverse. Okay, I don't know what is the inverse. Okay, let's call this as some capital X. I don't know what this X is. Okay, so similarly, this is very similar to 10 into some element, okay, should give me 1. 10 into some element, okay. So here we are doing multiplication. So let me just put that symbol here. So 10 into some element should give me 1. What is that element? So you will immediately notice that 10, if I multiply with 10 inverse, okay, or I can say 10 into 1 by 10 should be equal to 1, right? In a similar way, when I take C3 and I multiply with it inverse, okay, I should get E, because E, I said, is very similar to 1 in your math. Okay. Now I don't know what is the C3 inverse. How do I find it? Okay. So what I usually recommend to do is that you take ammonia molecule. Okay. So you take the ammonia molecule. You are doing okay. Now what you do a C3. Okay. You do a C3. What will be the answer? If you do a C3, it will be H3, H2 and H1. Now again you do a C3. Okay, let me just rub all this so that I get some space. Again you do a C3. What you get? So N, H. Let me not label this, and then okay. So 2. This will be 3. This will be 2. Now again you do a C3. Please note, if you do C3, you will get back to E, right? Okay, right. So if we do again a C3, so this will be H1, H2 and H3. Okay. Now, how many? So this, what is the relationship between this and this? You can immediately say that is E. So I started with C3. How many operations I have to do of C3 so that I get E? How many operations? I have done a C3 here. Okay, I have done a C3 here. Okay, so I have done a C3 here. Now, how many operations did I do here so that I get E? Okay, so you will immediately notice that I have done 1 and 2. So the inverse of C3 is twice C3. So we'll write it as C32. This is giving me E. Okay, so that's how I say C3 inverse is C32. Okay, so we'll write this as C3 2, right? Okay. So now let's do a C32. So let's do a C32. What you get here? If I do a C32, the result will be this. Everything H1 will move twice, H3 will move twice, and H1, H2 will be here. Okay. So what is the relationship between this and this? It is the same. So the answer is again E. So the answer is again E. Okay. So as we already discussed in class, so I'll just not do the rest of the things. I'll leave it for you to do it. Okay. So everything, please convince yourself that everything will be E. So what this means is that E is so everything you get E, right? So when you do similarity transformation on E by all other elements, you get E as the answer. So we say that E is a class on its own. So E can form a separate. So E is a separate class, other class. Okay, so that's what it means.